Hey, math friends. So our learning target today is I can review Unit 6 on exponents. So at the beginning of this is kind of the cheat sheet, if you will, of the properties, all of the properties we talked about, the property rules. You can see 7 listed here. So I'm going to go through those quick because we will need those as we work through this review. So if you have the same base and you're multiplying, you would subtract the exponents. So you would keep the base, subtract the exponents. It'd be a to the m minus n. I'm going to work down the list. Quotient division with the same base, a, you would subtract, whoops, I misspoke here. I misspoke. This should have been add. Sorry about that. This should be add. So multiplication is add. Division, sorry about that, is same base a, we would subtract the exponent m minus n, a to the m minus n. Negative exponent, if you have a negative exponent, it really means that you're going to invert it as a fraction, just getting inverted. So it becomes a to the positive n. Notice I lost the negative when it moved to the denominator. So the negative inverts it, so it just becomes 1 over a to the positive n. Power of power property, it's essentially kind of like the distributive property. It becomes a to the m times n. So this is multiplication here, a to the m times n. And likewise, when we have a quotient, we distribute, kind of the idea of distribute, it becomes a to the m divided by b to the m. And then power of a product property, we distribute, becomes a to the m times b to the m. So the m goes in twice there. And then the zero property, anything to the 0 power equals 1. It does not matter what the base is. We talked about how that is about patterns, and that's the y. Lots of kids think it's 0, but it's 1. So now we're going to use those properties for all of these learning targets on evaluating expressions. We're going to use power, quotient, 0, all the properties. All right, here we go. Same base, division is the operation. So we would end up with 4 to the 10 minus second power becomes 4 to the 8th power. So we're just subtracting the exponents. Same base, we're multiplying. That's t to the first becomes t to the 1 plus 9th power, which is t to the 10th power. Distributive property kicks in here. So we're just going to kind of distribute that exponent. Same base, we got the base here. It becomes 8 to the 3 times 3, or 8 to the 9th power. We're not adding those, we're multiplying those. So we're going to distribute that in 8 to the 9th power. Question 4, write two expressions that are equivalent to 8x to the 15th. Option 1 would be something like, sorry about that. Option 1 would be something like x to the 3rd to the 5th. So when we distribute that, that becomes x to the 15th. All right. And then other ways to look at it. How could we get x to the 15th? Well, we could say x to the 10th. So using this property right here. Oh boy, I got to pause the video. I got to fix the stylus. All right, I'm back in. So how do we get x to the 15th? We already saw 1. X to the 10th times x to the 5th. Same base. Whoops, I miswrote that. Sorry, my dog is driving me crazy here. X to the 10th times x to the 5th. Same base. The add exponent would be x to the 15th. So on this one, you were asked to write two expressions that would give you x to the 15th. This one works through multiplication, and this one, same base, add exponent. So tons and tons of options, but those are just two examples that would work. This says write as a fraction with no exponent. So negative exponent means we're going to invert that, 1 over 7 squared. Notice I lose the negative. No exponents, it says. Write as a fraction, no exponents, becomes 1 over 49. 1 over 49. Next problem, this is order of operations here. So we have the same like terms. So we would just add the like terms. The properties in Unit 6 all have to do with multiplication and division. That's an addition problem back in like terms of really just intro to algebra, pre-algebra, like terms. Question 7, write as a negative exponent. In this question then, we have 1, 2, 3, 4, 5, 6. So that would be 4 to the negative 6 power. Negative because it's a fraction, 1 over that quantity. Question 8, we're going to distribute that in through multiplication. That becomes 8 to the 18th. When it says simplify, you don't have to write it out on this particular lesson. Next one, which value of n makes this statement true? Well, this is really, if it's the same base, we're adding the exponents. So essentially, you are adding this equation. You're trying to find the value of n. So negative 4 plus n is equal to 10. So I'm going to add 4, copy, paste, copy, paste. So we believe that the n value must equal 14. So if we go back up and put a 14 up here, is that true? So we have negative 4 plus 14. Does that equal 10 for our exponents? Boom, nailed it. That's the n value. Cool, keep rolling. Write as a fraction with no exponents. So we're going to subtract here. So that becomes 3 to the negative 4th power. And that becomes 1 over 3 to the 4th power, which becomes 1 over 3 times 3 times 3 times 3, which becomes 1 over 81. So I'm using the idea that I subtract the exponent. Because I have a negative power, now I have to invert using that property, and it says no exponents here. So then I wrote it out in standard form, 1 over 81. Cool. Now I'm going to erase all that because I need to be able to write in the box for number 11. So go ahead, pause right now if you need more explanation on that. Next one, here we go. So we have 6. I assume that was multiplication. We have 6 to the 5 plus negative 8th power, which becomes 6 to the negative 3rd power. Directions say fraction, no exponents. So that's 1 over 6 to the 3rd power using that negative inverse property, which is 1 over 6 times 6 times 6, which I think is 216, but I'm going to throw it in my calculator anyway. Yeah, so it becomes 1 over 216. That is a fraction, no exponents. Remember, you add here when we're multiplying. Coolio? I'm going to have to erase again so I can work through that next box. Next problem says to simplify. It doesn't say specifics on how to write final answer. 3 to the negative 3rd, divide by 3 to the negative 5th. That's a subtraction then of the exponents. There's lots of ways to look at this problem, but that becomes, we're going to subtract that because we're dividing. So negative 3 minus negative 5. Ooh, look what happens here. It turns into positive. 3 to the positive 2nd, because here's the y. Negative 3 minus negative 5. Check it out. Ooh, that's exciting. That actually becomes the exponent of 2. And then it just says simplify, so you can keep that or that. You can keep it in exponential form or standard form. Next problem here, 4 to the 2nd power plus 6 to the 2nd power. Notice this says addition, so it's not in our properties rules from Unit 6. This is like terms. This is PEMDAS, so that's just 16 plus 36, which is 52. Now, I just threw these in here so that you're able to sort through when is it a property rule on multiplication division only. Anything with addition is back to pre-algebra of just combine like terms, PEMDAS. Question 14, boom. Division is the operation. I'm going to first do this step to kill that parenthesis. So that's 7 to 36. Divide by 7 to the multiply in 36. Ooh, some of you might be able to see what's going on here. 7 to the 36. Divide by 7 to the 36, FYI, is 7 to the 0. There might be some obvious things sticking out at you here, but 7 to the 0, which is what? 1. Some of you might be able to see from that step that of course, is going to be 1. Number 15 just says simplify. That's negative 8 to the 2nd power. It's just negative 8 times negative 8 is what? Positive 64. We knew that. We've known that for a long time in mathematics. Now that is slightly different. Now check it out. See how this one is protected in a parenthesis. It's a parenthesis grouping negative 8, and we need 2 of those. This problem down here is different. 16 I want you to take a peek at 15 and 16 over and over and over. Maybe I can keep them both on the same screen so you can see it. It is super essential that you know this. This is one of the trickiest things in math, of being able to sort through that. So this one says we're going to square the 4, which is 16, and then we're going to reattach or take the opposite of our answer. Notice it's not in a parenthesis. So this problem here, number 16, is very different than this problem here in 15 because of the parenthesis that is grouping that negative. FYI on that. 17 says simplify. Write as a fraction, no exponents. All right, boom. So we can do this. There's a negative exponent here, so we're going to use that inverse property. So that's negative 2 for the base. Make the exponent positive because we inverted it. It says no exponents. We're going to have to write that out. That's 1 over negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Check, check, check it out. So that's 4 times 4 is 16 times negative 2 is negative 32. So I'm just kind of doing that in my head there. You're welcome to use your calculator to help support you on that if you need. 1 over negative 32. Now, as a math teacher, I prefer my negative in the numerator. Notice the exponent. There's not an exponent that's negative here. The integer is negative. So negative 1 over 32. It says to write as a fraction, no exponents. All right, cool. I'm going to have to erase that so I can go to the next question. Oh, boy. Simplify, write your answer as an exponent. Looks like I lost my multiplication here. But this is the idea that this is the same exponent, so we can group the bases, which really then becomes 14 to the third power, kind of working opposite, kind of undoing the properties that we've been working through. So just be aware of that. See how we're just undoing those properties, pulling that exponent out. Since the exponent is the same, we can undo the base. Question 19, simplify, write answer with a positive exponent. All right, y'all. So this is really 2 times, I'm not going to write that all. I was going to write that all out, but that base has x to the 10th. I'd have to write x out 10 times. No thanks. So this is going to reduce to 1/5. Hope you can see that. And the subtraction is going to happen here. 3 subtract 10, which means we're going to lose all of our x's in the numerator, and we will have 7 x's left in the denominator. Because you have 3 of x's on the top and 10 x's on the bottom. So x, x, and x, those 3 x's will be canceled out on the top, leaving us with 7 x's on the bottom. And 2/10 reduces to 1/5. It says write the answer with a positive exponent. That's good, because I don't know how we would write it without one, with a x as a base. So here's your fraction. Answer is written as a positive exponent. We're done. Next property is going to combine 2 properties, actually. We have the new property that we've been learning, and then we're just combining like terms after that. So the property that we're learning here is that we're going to distribute it into both of these terms. So that's 3 to the third, x to the third, plus 4x to the third. Coolio. So we're going to clean this up. So this becomes 3 to the third is 3 times 3 times 3 is 9 times 3, which is 27x to the third, plus 4x to the third. Now the operation here is add, combine like terms. Are these like terms? Yes, this is back to pre-algebra now because it's add. 31x to the third would be your final answer there. But you have to start the very first step by sending that 3 into the 3 and that 3 into the x. So it's 3 to the third, x to the third, right out of the gate there. Make sure you send that in right away. Boom. All right. Next problem, coolio. These are all kind of funky rules here in this unit. So if I look step by step here, we're going to try to cancel some things off. I have 6 of these on top and 3 on the bottom. That leaves me with 3 on top. So that's 2 to the third, coolio. Next step, I have 2 3s on top and 4 3s on the bottom. So that leaves me with 2 of them left on the bottom. And this turns into a nice little number 1 there, because 4 to the third divided by 4 to the third is just 1. I got that. And now we're going to simplify. 2 to the third is equal to what? 2 times 2 times 2 is 8. 3 to the second is equal to what? 9. So your final answer is 8/9. Now you could write that all out. I don't have a ton of space there, so I didn't write that out, but you could write that as 2 times 2 times 2 times 2 and just expand it out and look for factors that cancel. All right, last page of the review, guys. Getting us ready for that test. This is a funky test as it has so many rules that you have to be able to sort through. All right, solving here. We're trying to figure out the value of n, so we know that we have to subtract. So that's really an n minus 4 has to equal this quantity, 5. So if we just use simple algebra here, we can find out that the n must equal 9. So let's check it out. Let's send in our investigative crew here. Is it true that 9 minus 4 equals 5? Yes. So we know that the n value is equal to 9. It says what is the n value to make the statement true. Final, n equals 9. Cool. Next problem. Again, I usually get lots of questions on this problem, so make sure you're tuned in here. We're going to distribute the 9 to the top and the bottom. That becomes 1 to the 9th, 4 to the 9th. Make sure you know that's 1 to the 9th, times 4 to the 15th. Now, when we simplify this, we can write this over 1. 1 to the 9th is just 1 times 1 times 1 times 1 times 1 times 1. So 1 to the 9th just simply is just 1. It's 1 times 1 times 1 times 1, 9 times. What we can simplify, though, is this. And we could stack it on top of each other. I'm just simply out of space. But I have 15 4s on top. I have 9 4s on bottom. We can use the property where we know we can subtract the exponent because we're dividing. Becomes 4 to the 6th power. 15 subtract 9. And it says leave exponents in your answer. Final answer is 4 to the 6th power. You might want to rewind that one and check it out because that is one I often get questions on. Next problem, simplified, leave your answer, leave exponents in your answer. Boom. Okay, we got this. Distribute, that's 20 to the 18th, that's a whopper, over 20 to the 3 times 3, which is 9. Subtraction, because it's a division problem, becomes 20 to the 9th power, and it does say leave exponents in your answer. So 20 to the 9th power. Boom. Hang in there. We're almost there. All right. Number 25 is going to be a little messy. Distribute. Send it in. Is negative 3. I'm going to keep that parenthesis there. Squared. X to the 3 times 2 is 6th times 5 x to the 5th. This is negative 3 times negative 3 because it's in that parenthesis there, which is 9x to the 6th times 5x to the 5th. Ooh, this one is exciting. So the coefficients here, we're going to multiply 45. And because we have the same base, this isn't like terms, this is a property that we just learned. Same base, we do what with the exponent? Same base, we're multiplying. What do we do with the exponent? We add them. 6 plus 5 are the exponents, which is 11. Final answer would be 45, x to the 11th. Again, rewind that if you got stuck at any point. So many properties involved in these problems. So many little things that can go wrong if you miss one of the properties. We have 3 terms in here. We have x squared, we have a 4, and we have x to the 5th. We're going to distribute to all 3 of those through multiplication. Distribute x to the 6th. Distribute 4 to the 3rd. I actually can't see that. And then distribute. So we distributed already here and there, and then distribute here. X to the 3 times 5 is x to the 15th. So when we solve that, we end up with 6 x's on top, 15 x's on the bottom. So just a 1 on top because we're going to lose all 6 of those x's, leaving us with 9 x's on the bottom. And then it says write your answer as a fraction with positive exponents. And so we'd have 4 to the 3rd here. That didn't change. Now you could write that out. So that's 4 times 4 is 16 times 4. You could also write that as 64, 4 to the 3rd, x to the 9th. Either one of those is they are equivalent. Reminder, from the very start of this, I had to send that exponent of 3 in 3 times to each of these terms. So it becomes x to the 6th, 4 to the third, x to the 15th, which is what I have here. Pause video, rewind. Lots and lots of stuff going on. All right, next rule. We have 1, 2, 3, 4 terms on the inside. That 2 needs to be distributed 4 times. So that's 3 squared, a squared, over 2 squared, b squared. I'm going to erase that, make sure I did that right. So 3 squared, a squared, 2 squared, b squared. It has to be sent in, as I stated, 4 times. Times b to the 6 over 12. Check, check, check it out. Now, we need to clean this up. Normally, I write this all out if I'm in class using a big board, but because I'm working on this tiny little screen here, I'm going to have to forego some of that. All right, what do we have left? We have, I think I'm going to write this out, guys. So we have 9. Where am I going to write this? I'm going to erase this problem just because I don't have anywhere to write. I might erase this one too. You might need to push pause and rewind. So that becomes, let's see, I'm working backwards here. 9 a squared b to the 6. I'm going to try to stack these if I can. This is 4, and this is a 12. And 4 times 12 is 48. And there's a b squared on the bottom. So we get 9 a squared b to the 6. I'm just checking my work here. On the bottom, then this is a 4 times 12 is 48 b squared. Okay. All right, moving to the left then here because of work. There's 6 of them on top and 2 on the bottom. We know that we can subtract that. We don't have any a's to subtract. So it becomes a squared b to the 4th. I lost everything on the bottom. And if I were to simplify this 9, I think of the factors of 9. Well, 1 times 9 and 3 times 3. Do any of these go into 48? Yes, they do. We can divide by 3 on both of these terms. So divide 9 by 3 and divide 48 by 3 is 16. So final answer to this problem when simplified is 3 a squared b to the 4th. I'm pausing because I'm just double checking that I think I'm cleaned everything up correctly. Yep. Over 16. Check, check, check it out. You might want to pause this one. Lots of stuff going on when we simplify. That's a toughie. Cool. Couple left. Scientific notation properties. The planet Jupiter is approximately 483 million miles from the sun. What is this number in scientific notation? So 483,000,000 million. Scientific notation has this rule that we have to have $1 to $10 in the bank, and we have to be multiplying by a power of 10. So if the decimal is here, we're moving it there, which is $4.83, which fits in the scientific notation bank. Step 1, and then we multiply by a power of 10. How many places did we move it? 3, 6, 8 places. Final answer in scientific notation using the rules of scientific notation. 4.83 times 10 to the 8th. Boom. Next problem, standard form, is to simplify to the answer. Here's our problem. The thickness of a sheet of paper is about 9.7 times 10 to the negative 2 millimeters. Super, super thin. What is this number in standard form? So we have 9.7 times 10 to the negative 2. We're just going to move 2 places to the left. So we're going to take this decimal 2 places to the left. Becomes 0.097. Answer is, in standard form, 0.097. Question 30. The height of a building is 8.048 times 10 to the second power. What is this number in standard form? This means we're going to move 2 places to the right. So we have 8.048. This is the height of the building. Again, just pause the video whenever you need to. I'm just going to keep going at this pace. Just push pause if you need to read it again. You're not quite sure. I have to do that all the time when I'm helping my son with his math videos and any kind of video. Just push pause, rewind it. What is the number in standard form? We're going to move 2 to the right because it's positive. Boom and boom is 804.8 in what we call standard form. So it was given, both of these were given in scientific notation, and you move to standard form. Scientific notation, move to standard form. So we're kind of working back and forth. All right, y'all. Last 3 problems of the day. Hopefully you're getting ready for this test, which does require some practice. You have to practice for math test. Write out a bunch of problems, practice them over and over until you're super confident with the skill. This is a calculator problem that E just stands for times 10. We do talk about that in the other videos and in class. So this really is 2.3 times 10. I don't really like using that X for scientific notation, but that is how it is written because it looks confusing like a variable. But that's how it's written. Standard form means to simplify this, we're going to move I misspoke. We're going to move 5 places to the left. So we're going to take this decimal and go 5 places to the left would be 0.000023. Standard form. I'm going to verify. Verify team. Starts here, goes 1 and then 4 zeros. Yeah, boom, nailed it. That's standard form. Question 32 is find the quotient, means divide. Write your answer in scientific notation. All right, here we go. So we're going to divide 3/4. 3 divide by 4. Type it in, type it in, type it in. Unless you know that 3/4 is what? 75 cents. You knew that. Now we are going to subtract our exponents here. So 10 to the 6th power. Now this is an answer, but it says specifically make sure that your answer is in scientific notation. And this one is not because this 75 cents doesn't fit in the scientific notation, aka bank. The bank only accepts between $1 and $10. So we're going to rewrite that as $7.50 placeholder, 50 cents. 7.50 would work because that would fit in the 1 to 10 bank like we talked about in the scientific notation video. So if we make the decimal, if we move this to make the decimal bigger on the what we call the coefficient, we need to go opposite on the exponent. So we're going to make the exponent smaller by that 1 unit. Now I'm in scientific notation. Those answers are equivalent. They're just, we need to get in the correct form, the correct notation, scientific notation required for that last step. And final problem of the day. Find the product, write your answer in scientific notation. So the product would be multiplying these 2 coefficients out front, which is 16 times 10 to the, add the exponent 6th power. Now, this 16 doesn't fit in the scientific notation bank. The bank only fits $1 to $10. It's too big. So we need to make it smaller so it fits. So $1.60. Imaginary placeholder there. So we took the decimal, we made it smaller. If we make the coefficient smaller, we do opposite on the exponent. We make the exponent bigger. So 1.6 times 7 is now in scientific notation. So this is a 28-minute video on exponents because it covers I'm not done. Because it covers everything in the exponent unit. Everything in the unit in preparation for the test. That is why I'm talking at the speed I'm at, or the video would be about 2 hours long. So you just simply have to push pause. The human eye blinks about 6.25 times 10 to the 6 times each year. So that's how often our eyes are blinking. About how many times has the eye of an 8-year-old blinked? So we're really saying an 8-year-old would blink 6.25 times 10 to the 6. An 8-year-old's done that per year for 8 years. So that's multiplication kicking in. So we're going to multiply these 2 coefficients. So 8 times 6.25, which is 50. That means 50 is when we multiply the coefficients. And we don't have anything to do with this 10 to the 6 yet. It says it has to be written in scientific notation. Well, $50 is too big to fit in the scientific notation bank. It has to be between 1 and 10. So we're going to move the decimal and make it sure it fits in the bank. Now it fits in the bank. If we make the exponent smaller, we need to, I misspoke. If we make the coefficient, the number out front, smaller, we have to do the opposite with the exponent and make it bigger. So my final answer is 5 times 10 to the 7th. Cool. 35 is our last problem of the day. I kind of lied before when I said we were done. United States has a population of 3.1 times 10 to the 8th people. China has a population of 1.3 times 10 to the 9th people. right? Or what is the ratio of China? Ooh, this is out of order here. China population to the United States population. Make sure you read the question carefully. So China's population is this, and we're going to stack that on top because that's what it says to do, China over US. So 1.3 times 10 to the ninth, divide by 3.1 times 10 to the eighth. All right, all right, all right. Division kicks in here. Divide the coefficients, 1.3 divided by 3.1 gives us, I'm just going to leave it at that, to the thousandths place. And we subtract the exponent, which is 1. Now it says specifically that we need to write our answer in scientific notation, right? So it says that. Write answer in scientific notation. And the problem we have right now is this doesn't fit in the bank. It's too small. It has to be between $1 and $10. So if I move the decimal to $4.19, it fits in the bank. If I make the coefficient bigger, I have to make the exponent smaller. So that becomes times 10 to the 0 power. So it'd be 4.19 times 10 to the 0 power, which is essentially 1, right? But if it's asking for scientific notation, you do have to write it in that notation, even though the exponent is a 0. So this is your review assignment. It's same as the packet that you were given. All the answers, of course, are on the last page when you're working through that packet. But this is the video form of that packet. Make sure you're ready for this test. This test is deceiving. You think exponents, you think easy, but with the 7 rules that are embedded in here, you really need to be able to distinguish between which rule you're using and when. Okay, make sure you're ready. This one takes some practice. Have a glorious night.